Hey, welcome to The Explainer. Today, we're going to tackle one of those huge, mind-bending concepts from modern physics. You know the kind, all wrapped up in a single really elegant and, let's face it, pretty intimidating formula. So let me ask you something, right out of the gate. Do you think you've got what it takes? To solve one of Albert Einstein's most famous equations? Well, stick around, because we're going to find out together. All right, Section 1, a cosmic equation. We're kicking things off here because, look, what we're about to dive into, it's not just a bunch of letters and symbols. Nope. This is a statement about how reality itself is put together. And there it is, the time dilation formula. This is a huge cornerstone of Einstein's special relativity. I mean, this is the math that proves time can literally slow down. It's the engine behind all that cool interstellar travel you see in sci-fi, but it's also the reason your GPS actually works. Seriously, it is a true titan of physics. Okay, so our mission for this explainer sounds simple, right? We're just going to take this incredible formula and solve it for the variable t. That's it. Let's think of it as our grand intellectual challenge for the day. Okay, moving on. Section 2, decoding the variables. Look, if you want to crack a big puzzle, you got to know what all the pieces mean, right? So let's start our investigation. Every single symbol you see is a clue. First up is the letter T. This is our main target. T represents what's called dilated time. So imagine you're just standing still, watching a spaceship whiz by at some crazy speed. T is the time you would measure for that spaceship. Okay, next up is T sub 0, or what physicists call proper time. So if T is the time we see from the ground, T sub 0 is the time the astronaut on the spaceship experiences. For them, it's just normal time ticking by on their watch. Then you've got V. Simple enough, right? It's just velocity, how fast that spaceship is moving compared to us. But, and this is the fun part, as V gets bigger and bigger, the difference between our clock and their clock gets, well, it gets really, really weird. And last but not least, C. Now, this isn't just any speed. C is the cosmic speed limit. It's the speed of light in a vacuum, and it is a totally fundamental, absolutely unchangeable constant of our universe. You could almost say it's the anchor that holds all of reality together. All right, Section 3, the method of solution. We've got our mission, we've decoded our clues, now it's time to lay out our plan of attack. This is where we bring in the heavy-duty mathematical rigor, to really crack this thing open. So let's be professional about this. State our objective formally, just like a real scientist. Our goal is to perform the necessary algebraic manipulations on the equation to isolate the variable t. And here's our official 3-step process. Step 1, state the explicit goal. Check, we just did that. Step 2, carefully examine the equation. And step 3, draw a conclusion based on what we see. Seems simple enough, doesn't it? And that brings us to Section 4, the astonishing answer. We've made it. After all that work defining our terms, outlining our super rigorous method, we are finally ready for the big reveal. So, after all of that work, right? After defining every single variable and carefully outlining all the steps for what we thought was a really complex problem, here it is. The solution. The equation is already solved for t. Yep. That's it. The whole point of our epic intellectual journey was that there was no journey to take. There was nothing to solve. I mean, let's just look at the formula one more time. There it is. See it? Done. It's sitting there all by itself on the left side of the equal sign. It was already isolated. Our entire grand quest was over before it even started. And that kind of brings us to a final thought, doesn't it? Sometimes we get so wrapped up in thinking a problem is going to be hard that we completely miss the solution when it's just staring us in the face. So I'll leave you with this question. Maybe the hardest part of solving a problem is just knowing when it's already solved. Thanks for joining me on this one.